My name is Chris Bergh. I have a long background in both software and data, a very technical person, and I have a particular view on data and analytic teams and their challenges. And it's sort of rooted in my experience running teams of data scientists and data engineers, rooted in our history of our company. So I'm going to talk about that. And then I'm going to take that experience and apply it to kind of the world of AI and really the world of large language models. And so our perspective is kind of life is an unproductive mess for data and analytic teams. And AI is kind of making it worse. And so how do you live in that world? So let's talk about that perspective. So I've did software for about 15 years. Worked on an AI project at NASA to automate air traffic control, MIT, startups, Microsoft, and 20 years in data. And kind of I've learned really three things, honestly, over those years. First is you're going to get crappy data from your customers, and shit's going to break. And when your customers are always going to ask you for new things, and they're not going to know what it wants until they see it. And you're always going to have too much to do. So your every data team I've talked are always caught in some form of this problem of I've got bad data, things are breaking, my customers want a lot, and I'm pretty stressed. And so you have this sort of crisis of both productivity and stress in data and analytic teams. And in our organization, we talk to customers, and I'll bring up a customer I just had this morning and sort of talk about that their crisis. And so for the last dozen years, Data Kitchen, we're trying to fix this problem. And we've put the moniker on it called data ops. Now, words in data and analytics systems mean a lot or don't mean a lot because they get abused. But we've run this sort of profitable independent business and we've done data engineering using these data ops principles. We've written books and trainings and conferences, management consulting, and we've done some sales. And recently, the past couple of years, we tried to sell to chief data officers for many years. That was frustrating. And so we've invested sort of $5 or $6 million of our own money in building these open source data quality and observability tools, really in the hopes to drive data ops adoption. And so what does this mean, this whole word of data ops? Well, the first thing is that when you're getting insight from data, you're really running a manufacturing line. So you bring data in this picture from one side, you're accessing it, you're transforming it, you're modeling it, you're visualizing it, you're reporting. It's a step-by-step process to take data, integrate the data, visualize it, distribute it, run models on it. And so the metaphor is you're running a manufacturing line, and sometimes we call those pipelines. Sometimes we call those jobs. Most companies have dozens or hundreds of those in production, and you want your assembly line of data to produce good quality. You don't want to produce crappy cars. You want to produce sort of Toyota Corollas. And then the second is you've got this other process going on in your data and analytics system is you're changing things. You're adding new code, new configuration. You're iterating. You're trying to learn what your customers do. And in both of these, what we have called, and in our books and writing, we've called these two pipelines. One is called the value pipeline, where you're trying to deliver value to your customer, and the other is your innovation pipeline. And the struggle here is that you just don't want to learn about problems from your customers. And when you change something, you don't want to break something that's already there. And these are very hard tensions in organizations. And sometimes they're solved with people working late at night, stressing, being heroes. Other times they're solved with sort of bureaucracy and slowness. And both of these things are not optimal outcomes for teams. And so, however, if you work on these things, if you try to work on these processes of running a factory with high quality for insight, being able to make changes with ease, your actually team's productivity is going to go way up. And we've got studies on this, a lot of studies on this. And this parallels sort of the lean manufacturing movement in when you're building a car, or the sort of agile and DevOps movement, and sort of these ideas where we've tried over the last decade to bring forward into the data and analytics teams. And so given that background, like it's hard to be in a data and analytics team. And here's an example. So I talked to a network of hospitals here in the East Coast, a really large network. And they've got data warehouses, a couple of data warehouses, and all the data that's going to the data warehouse is kind of completely open. They don't really know if it's correct. They've got hundreds of jobs running. They fail. They get notified by their customer, and so they're just it's a very stressful life that they're always hearing about problems, and they have no automation to help them. Their customers are demanding that they deliver with higher quality, and yet they have this whole long task list of work to do. And so this is the life of most data and analytic teams today, and one of the reasons why we want to um, continue to help them. And so what's made it worse, I think, is AI, right? Because of course you can't um, live today without hearing the word AI, and it is awesome, but it's also going to make this mess of data and analytic teams much worse. And really in two parts. One is that um, there's an opportunity now to take all that data that we use for insights and apply it into an LLM to give insight. Um, and then there's another part is that AI itself is creating more insight, creating more code. And so I'm going to talk a little bit about both these use cases and why they're so hard. And so in this case, I'm going to use the word AI, but I'm really going to mean large language models. I mean, AI could mean a lot of things, right? It could mean a regression model. It could mean a clustering algorithm. But in this case, when I'm using AI, what I really am talking about are large language models. And what's happening right now is your analytic engineers, your data engineers, they're doing something called vibe coding, which means they're taking your data, the columns, the existing code, they're using something like Claude Code to actually create tables, create data transformations, to create Python code, to configure BI tools. They're doing it right now. It's very easy to do it, and maybe it's not even your analytic engineers. Maybe it's your product managers. People are and I'm going to talk about this a lot. The AI is a really opportunity to expand the scope of who actually creates code. And maybe as a previous, our keynote talked about today, maybe the cost of software is going to zero. But what I do know is that the number of people who are actually creating code is increasing in your organization. And that's a good thing. And so and then the other part is people are taking your data and they're using Claude or ChatGPT or a version of that that's embedded in their BI tool or the particular tool that they're using to analyze data directly. So one is that there's this creation, that large language models of code that's happening. And second is there's this consumption of data that models are analyzing directly. And the challenge with both that is LLMs hallucinate, that they're confidently serving up garbage sometimes. Sometimes it's amazing and sometimes it's garbage. And you've still got your whole data stack. You've got your predictive models, you've got existing reports, you've got work on the data and data engineering work that you have to do. And they change and they degrade. And of course, everyone wants AI magic, right? Because AI can do everything, which of course it can't. But so we have this challenge now of AI invading the data and analytics team. Is that one is, you can create more code, lots of more people can create more code. And then the tool itself, ChatGPT, Claude, your LLM enabled BI tool is grabbing data in and analyzing it. And so how do you deal with that situation? And so that's kind of what I want to talk about. And as a preface, I want to talk a little bit about why we're never going to get 100% perfect results out of a model. And so I began my career in the 90s working at NASA Ames. I worked on an air traffic control automation problem to try and provide automated assist sequencing and spacing assistance for air traffic controllers. And we got into production at a bunch of airports. It was super cool. It used, at the time, constraint satisfaction, fuzzy logic, all the hot 90s AI technologies. But it could only go so far. It got sort of 80, 90%. And then every 1% was just harder and harder, almost asymptotically harder. And what we found is that we really needed to make the machine work with the person. And so in some ways, we spent most of our research time trying to figure out how to take this cool algorithm and make an interface to assist a user. And I think we have this very general technology in large language models. And because they're always going to be inaccurate, and because improving accuracy is always getting harder, you can see that in model results. LLMs are always going to deliver imperfect results. So, how do you take this great tool and assist users with it? And so, given that background, let's talk about these two cases of how AI is expanding the world of data and analytics, and what it means for you as a data engineer or a data scientist, or someone who runs a data and analytic teams, or someone who does data governance or data quality. So the first case is an LLM is kind of an analytics interface. You can put data into a large language model, and it can actually make predictions or analyze data. And it's getting better and better because of the increased size of the context window. And this may be just as you connecting to an interface to your database, an MCP interface, and maybe you copying and pasting data into the model. The model may be actually embedded in the tool, but LLMs are actually analyzing your data, and they're doing just what LLMs do. They're doing a pretty good job. They're often wrong, but it's hard to tell the difference. But it's really useful. And then the second case, as we talked about, people are using and creating more code. They're using, Claude Code to develop. They're using their cursor. They're using their favorite tools to create more code that wants to be put in production. And that could mean they're creating more DBT models. They're creating new Python code, et cetera. So let's talk about this first case, LLMs as an analytic interface. So what does that mean? So what it means is that you've got your data from your internal systems, and that could mean rows and tables. It could mean unstructured data. It could be some metadata or some contextual data, and that's being put into an LLM in some shape or form, and then people are getting insight. And so you can almost think of it as there's a new interface to data out there that used to be, maybe you looked at it in Excel, or maybe you looked at it in your favorite BI tool or your favorite SQL query tool. But now it's actually being embedded into these chat dialogues. And so you're conversing with your data. It becomes a conversational interface. And so there's a whole discussion going on now in the BI world about whether BI is going to be completely eclipsed by LLMs, and these sort of conversational interfaces are going to replace notebooks, are going to replace dashboards. Perhaps not, but this is what's happening today. Is that this is going on, and so the challenge here is that means that people are going to take more data, and they're going to use more data to do this. And so all those data stores, people are going to be copying and pasting, or they're going to be automatically analyzing it with a large language model. And that's great, right? But it also has these challenges, right? So let's think of it this way. So look at an expected value calculation. So bad data sort of compounds the LLM error. So for example, let's say you have your data, and your data is maybe 80% correct. And we don't have to get into how to judge sort of correctness or data quality. But you could, we have a scoring tool that does it, other people do it. But your model itself is always going to be 80% accurate. It's always going to be 20% wrong. So if you take 80% times 80%, your expected value is 64%. And so that's not great, right? That means 1/3 of the time it's going to be wrong. And so you can't, the models themselves that your company uses, or that you have chosen to use, that they're increasing accurate, but they're not going to get to 100%. And so how do you improve this? Well, you have to focus on the data. You have to focus on improving the quality of the data. And there's more data being used, and there's more opportunities for people to put bad data into models that are 80% accurate and get even worse results. So how can you help that? Well, I think there's an idea or a word that comes out of software's DevOps called shift left. And the idea is, if you find problems sooner, it's going to save time and money. And so one way to think of it is it's 10 times cheaper to find a problem in the source data than after someone's used it to actually make a business decision, or or it's been integrated into a data warehouse and put in a report, or in a factor dimension. And so there's this, think of it as the 10-100 rule. Like it costs $1 to fix something in the raw data, $10 to in the integrated data, and $100 if it ends up in your customer. And so if you find problems in data sooner, you're much better off because it hasn't. And again, this large hospital system I talked to, they're doing none of this, right? They have no automated way of checking. And so what this means is that your AI and your LLMs, that they need test coverage because AIs are and people are grabbing more data. You need to check data automatically and you need to improve your test coverage. And this is another term that comes from software. You need to make sure that you're automatically checking your data. And you need to do it all over the place, right? Most people will have data warehouses or data lakes or data stores. And every table that you have in that database should have tests. And every column in that table should have tests. And every significant business metric should have tests. And if there are tools acting upon the data, those should also be monitored for errors and timing. And so the idea here is that because people are analyzing data through LLMs, there's a need for more data. And if you're going to have those AIs be able to make accurate predictions, you've got to check the data and improve the data or fix the data before it gets to those models. And so what does it mean to have test coverage in data? Well, there's lots of different ways to automatically check data. And so if you're looking at every table or every column, well, one is you should look at, has the table changed in size suddenly, or has it shrunk, or has it not been updated, or someone changed the schema? And then in looking at every column, you should look at those things as well as the distribution of items in the column. And there's a whole bunch of different methodologies that we've instantiated in our open source or other open source tools that do that. And then every significant business metric, and this is a really important thing that a lot of times, if you've done data and analytics for a while, you've put a report or given a data to a customer and they look at it and within a half second, they go, that's wrong. And so, it's annoying when that happens, mainly because you took all this calculus in college and this person, who's looking at it might have been a business major, but your customers memorize metrics. And if you get those metrics wrong or there's suddenly change to them, you should know about it. And so looking at it, at your data or the things created from the data in the eyes of your customer is a very good practice. And so, and then every tool that's using data, you've got to check if it's had an error or if it's metrics or if it's tasks or it's timing, all these pieces that go into covering tests on data and on things that are using data to make sure that it's used not only by your current reports or your current models, but LLMs. And so how do you measure it? Well, that's a really interesting thing. In software, there's sort of a test coverage metric that you can gain and you can look at it and say, I've got enough coverage. And I've managed a number of software teams and you can look at the amount of unit tests they have or by looking at the code, the amount of tests or the amount of end-to-end tests or functional tests and gauge how hefty those automated tests are. And in general, we don't have that in the data and analytical world. We don't talk too much about test coverage. But just some rules of thumb, like every table should have at least 2 tests, every column should have at least 2 tests, every metric should have tests. You should check every tool that you're using to produce insight for errors and metrics. You should make sure that you check every log at least a couple times. And so that's a lot of work actually to go in and check that and make that happen. And like if you look at it, let's say one of the favorite architecture patterns in data and analytics is medallion, where you have a raw, a silver, and a gold, 3 layers of data, and then you perhaps have tools on top of it. And so this example one has got 3 database levels and 3 tools. It's got an ETL tool, it's got Airflow, it's got DBT, and sort of 5 jobs. So if you add all that up, right, I've got 100 tables with 10 columns. That means, well, I should have about 2,000 tests at each level. And then I've got jobs and tools. And so you end up with thousands of checks that you need to write in order to have good coverage. And that's important, right? Because what happens a lot of times are people are very busy and they don't have enough time. And automated checks and monitoring get put by the wayside. And so this art of writing tests, and so this is a thing that I've learned in my last 10 years, is for many years I applied the analogy, since I was a person who could do data work and also write software code. I was like, well, and when I wrote software code, I wrote a lot of tests. I used to do a lot of simultaneous develop some code, write some tests, develop some code, write some tests, sort of test next to. And I did the same thing when I was a data engineer, when I was doing some data science work. You know, sort of build a little, test a little, learn a lot was what I learned at NASA. And so, but it doesn't really scale to do that. And it's most teams are kind of confused. What test do I write? How do I check data? And if you look at that case, I've got 2,500 tests to write, and each test takes 30 minutes. Then here you've got 7 months of work to do that. And in a lot of cases, data engineers don't know what's important, what tests to write. And so and it's gotten worse with AI because people are using more data. So in some ways, we need kind of an AI to fight AI. And so that's sort of what we've built here in TestGen. We've built a tool that will learn your data and build hundreds of data quality tests that run in your data based on a semantic model, based on 51 column level insights. And so this is completely open source. It comes with a full featured, all the tasks, all the profiling, and a nice, simple UI. And it also comes with a data catalog. It comes with data quality scorecards. And the reason that we've done this is just we keep running into companies they don't have any tests. And I can't, to the life of me, I still can't understand how, I can understand how people end up in this situation like this hospital chain I talked to this morning, but it just sucks to be in that team where you're manufacturing something, and the only way you know if it's good is if your customers don't yell at you. You want to be able to monitor and check your data and your tools pretty accurately, and so we've built this tool that automatically creates data quality tests for you. And my belief, just like comes out of my experience, is that you can get a tool that can give you 80% of the data tests you need. 20% of them are always going to be unique based on if you're running a hospital chain or if you're running a retail company. They're very different. And so we've basically tried to make room and have some nice UI for you or your data stewards or whoever to create those business custom tests that are unique to your domain. And so let's talk about the second case now of where LLMs are expanding the pool of users who are creating more code. And so I put this together, and hopefully you'll like this way of thinking about more code. And so to do that, I'm going to talk a little bit about the history of code. And so I don't know if you know, like coding was actually originally women's work, and then quote unquote women's work. So the first original software engineers were mostly women. And then, the 60s, the 70s, of course, men took it over. And there was this sort of what I call the deep nerd coding era, right? Where how you learned to code was kind of books and man pages. If you wanted to, maybe you looked at your buddy's code or the other code in the project, but like there wasn't a lot of resources. So you had to like figure it out. And so in this case, like in the 90s, like if you went to Stacy's Books in downtown Palo Alto or here in Boston, there were two bookstores one called Quantum or Soft Pro. You'd go get a book, and you'd really have to use both those limited resources. And so it was tougher, but certainly possible to do it. And then really for the past 20 years, we've got this, you've got sort of search and Stack Overflow. And I call it sort of the tech bro coding era, where you could kind of program by analogy. Someone answered a question on Stack Overflow, somebody wrote a blog, you could search for some code on GitHub, and you could kind of find how other people were doing it and look at their code, maybe copy it from the browser and paste it, and then start coding. And so that really expanded the number of people. And so for a guy who learned to kind of cut his teeth in coding in the 90s, I always, sort of chuckle at the tech bro coding era, but I also found it very valuable that coding in the last decade was just so much easier because you could search and find. And so what's happened now is that all that information's been hoovered up by models. And so we're in this sort of vibe and prompt era where almost everybody codes, right? And so there's going to be more people, and they may not even know they're coding, right? It may be the whole LLM baby ensconced in a whole nice UI in their application. And so all of a sudden they get a new table built or a new data transformation. They get a new predictive model. And yeah, it's code. They may not know it. And so more people will building new tables, new reports, new models, new use cases, lots and lots of SQL. And think of it as kind of a vibe coding extravaganza. And again, this is great, right? Instead of this restriction, we're expanding the scope of how people actually create interesting work in data, which could be data transformations or whatever. And so think of it this way: more code's being going to get created by more types of people. And I could use Claude Desktop to help me write SQL. I could use the AI assistant in my favorite tool. Maybe I'm using Matillion and it'll help me write some Matillion code. I could also use Claude Code to write some Python. And your boss and your customer are kind of all doing these sort of actions today. And it's going to get better or worse depending upon your perspective. It's going to I think we're just at the start of more people creating this, and I think this is a good thing for um, just like if when you've gone through these different ages. Of course, I was never in the women's work age, but I've gone through three of these. It's always a good thing. It's a challenge, but it's a good thing that we're having these and this expansion of roles and people. And so, how do you do that? Well, it also goes back to LLMs being challenged, right? So if you look at a lot of work that happens in data and analytics is writing SQL, and LLMs are getting better, but not really that great. I mean, they're still 60% accuracy. They're in our tests, they're pretty terrible with having dialect specific. They mix in dialects from different databases, and so, but still, they're helpful, right? You're going to know business context. You're going to have to use some judgment to get what you want. And yes, there's context around the data. So there's things like your data catalog, there's data lineage, there's data profiling results, data quality tests. This context does help kind of formalize some hidden knowledge, but context is not a miracle cure. You're still going to expect more code and you're still going to have worse quality. So how do you deal with that? Well, there's another concept that we think is similar, is that shifting down. So the earlier you find these problems in the development cycle, the better you're off. And it has the same pattern. It's if you can find things, it's the same 1 to 10 or 10x pattern. Finding things early in the development cycle is important. And what that means is you've got to actually think about regression testing now, and full coverage regression testing. So you want to be able to find problems in code in a development environment. And so you want that, there is no magic here. You need to push data into a copy of your data and analytics system, realistic data, and run it and run tests against it. This is just like software engineers have done for years. And so it sort of pushes this need of test coverage into a really a dire need for regression. And because what will happen is, if we don't, we'll create more and more complexity, and that complexity will be harder and harder to manage. And so regression testing, end-to-end testing, functional testing, unit testing, this discipline that's been developed in software, AI actually really makes it important in terms of data and analytics. And so we have a tool that can help with that. We have an open source observability tool that's addition to TestGen. And what it does is it looks, instead of looking at the data, which TestGen does, it looks at the tools acting upon data and tries to tell if there's a problem. And so that's one of the challenges in these data and analytics assembly lines. We're assembling data, but the assembly line itself, the moving, the conveyor belt isn't well monitored. And so we've built this tool that does that. Again, it's full featured open source. And it provides that single grain of glass. So, what's the conclusion here? So, as I finish up, we've got these. It's really about AI is going to have more use cases. So there's going to be more data, more testing. So you need to shift left. Do find problems earlier, find it automated, and you need to shift down. And so you need the sort of AI to fight AI. And so, we put a lot of work and millions of dollars into building this open source tools. Our customers have found it really valuable. And we've built a company that, because we're independent, because we're profitable, we have a very fixed fee with unlimited usage, and we have a white glove user experience. And we've also have a lot that we've given to the greater community. We've got these open source projects, but we've written a lot. We've got 2 free books. We've got 2 or 3 free certifications, all of which have had thousands of people take to get educated on these ideas of how to apply lean manufacturing, DevOps principles, Agile to data and analytic teams. I put the links here. So that's it. And from for my talk here.